Assalamualaikum and good morning everyone. So we supposed to have 10 participants. So currently we have 1, 2, 3, 4, 5, 6, 7, 8 participants. Okay, good enough. So welcome to CAE. Firstly, I will introduce myself. My name is Mazrun. So you can call me Mazrun, tapi it will be best kalau you jangan panggil I sir lah. A lot of people here would like to call me sir, but I don't really like it. So you just call me Mazrun. You can call me brother. You can call me cikgu. If you are not familiar with brother, then you can call me cikgu. Or Mazrun will be best lah. Tapi jangan call I sir. I kurang berminat. Alright, so welcome to CAE. Our training program today is A321 new Gen Fam and differences caused with A321 new ACF. So I will explain the introduction later on. So we got 8 participants. I've been taking you for 2 days program. And actually, I been in CAE for more than 10 years, I believe. 14, if I'm not mistaken, 14 years. Before that, I was in Unicam Riyadh. I also been into several industries like Transmine. And I joined Asia in 2010. After that, then Asia Academy become CAE, and I'm here until present. So in the aviation, I've been in the aviation experience since 1999 and until today. Currently, I'm designated as CAE as type training instructor. I've been teaching 320 type training and also some other support classes, support training. For example, like AGR, horoscope, basic training, and many more. Alright, so that's a little bit about me. So let's do some introduction. I would like to know where are you guys coming from. Let's start with. Alright.
Hey, good morning, sir.
Morning.
So my name is Randy. I'm from Kuching Station. Yeah.
Bila sampai?
Semalam.
Semalam. Okay. Flight balik bila?
Besok.
Besok. Okay.
Been on A320 for 3 years.
Okay.
Senior.
Berapa? 3 years with ADE.
Yeah. And with 320 also.
Okay. Sebelum ADE?
So sebelum ini dengan Sapura.
Oh, okay.
So sebelum Sapura, I was in military.
Oh, okay. Sapura station dekat JB ke?
Ya, JB.
Dekat JB?
Yes.
Okay. So sekarang okey lah, balik kampung lah, bikin Kuching. Okay. Alright, next one.
My name is E. I'm from Kuching also.
Okay.
I start my first job with Aviation too.
Okay.
Sudah 14 tahun sudah.
Okay.
Sebelum ni fresh grad dari
College, masa di college, grad dapat dah dapat B1 ke, dah dapat B2 ke, ataupun
B1.
along the way.
belum dapat bilang, tapi sebelum itu saya sempat apa itu dibuat biasa sebagai tidak mau pulang.
Tak dapat promotion. Okay.
Jadi dapat EA lah pergi CNA.
Okay. So since Asia lah, and then join ADE. Okay. So
Good morning. My name is Shafiq.
okay.
Currently working at the
Base maintenance. Okay.
my training in 2019.
Masa vendor tu kena COVID ke? Kena COVID?
Apa stand up.
Oh, okey. Lepas tu dia tak renew kontrak kan? Lepas tu lepas COVID ada buat kerja
Join vendor lain.
ada juga vendor lain. Tapi berapa lama vendor lain?
1 year dekat store yang
Oh, lepas tu baru ini.
join vendor lain lepas tu baru jadi.
Okey. Alright. This one?
Ini Muhammad.
Okay.
Saya join ADE 2022 juga.
Okay.
Sebelum ni vendor dekat CI
Berapa lama tu?
3-4 years.
Okay.
Habis belajar daripada ANN.
Oh, bila join ini
2000.
2010 sampai 2002 sampai sekarang. Okay. Alright, next one.
My name is Alamin. Yesterday marked my first anniversary with ADE.
Okay.
So
Setahun ke dua belas?
Setahun.
Okay.
I've become a B1 certifier for A320 family around 2 months. I just got my approval on last December. So before I joined ADE, I was with Malindo, or now known as a Batik Air. I was a B141 certifier for ATR 72600 for about 6 years. Completed my basic training with Develop Training and Services, joined 2011 and completed my training around 2015. So I got my basic license on 2016 and joined Malindo. Malindo was my first company and ADE is my second.
So di lock dengan
Malindo and so ADE is my second.
So batik tengah cari orang tak boleh.
We have to move on.
Tapi batik sekarang dia dah offer white body juga kan?
Yeah, A330. Just that if I join them, I need to get the 73 first lah. So have to get another bond.
Batik ada operate 73 max.
70 NG and 73 max, but mainly the domain is max lah. They have more max than NG.
Oh, okay.
So they started to phasing out the NG and focus on max lah. So now max and A330.
Pada AD.
Yes. Yesterday was exactly month lah.
Okay. Next one.
Good morning everyone. My name is Ernest. I actually joined last year, 16 October. So, currently here as a CSI. Yeah. So waiting for 6 months. Waiting for
Untuk qualify lah.
collect qualification. Then
Sebelum AD
before this, I was with Sabah Air as a QA.
Sabah
QA for Airborne and Camo.
untuk AMO dengan KMO.
Yes.
Masa tu lah. Masa tu strike ada berapa orang dekat Sabah
Strength QA. QA only QAM and QAE me and one QA admin.
Oh.
So I'm the one who driver of it, product of it, for renewal, approval, KO and demo.
So title saja QAE tapi dia punya job function dah macam QA manager lah. Okay. Not surprise Sabah GA apa operate?
This is a QA.
Okay.
They offer a lot of modification and certification for the aircraft because small component they need to do all it.
Contoh aircraft?
They do a nomad, King Air and also helicopter.
Oh, okay. Okay. So tak ada intention lah balik Sabah ke?
I have but we the
Okay.
been working with DE for 3 years at full base angle. Previously, DE is my first company. Before that, I was a trainee at DE.
Dilok.
Yes.
Okay. Bukan daripada Asia, join terus ini.
Yeah, joined first.
Okay. Ada currently ada buat license ke tak?
I'm waiting for company procedure to be on.
Oh, dengan UA lah. Okay, B1, B2. Okay. Next one.
Hi, my name is Aisha.
Okay.
Currently, I'm B2 LAE at Bugis, Canada.
Okay.
I just joined ADE last year, July. Before that, I was in SAS, working on United for 3 years. I think almost 3
3
years.
tahun.
Almost 3 years. Before that, I was in SAE.
So SAE berapa lama?
SAE 2 years and a half.
Okay. Sebelum SAE?
For SAE, I did my license in Bidok. So,
So SAE, SAS, exercise B2 lah.
SKS.
SKS.
Yeah, SKS Airways. Yeah, SSS B2.
Oh, sana ada berapa? Ini?
Saya ada 2 twin otter, tapi SKS now dah close down.
Oh. Okay.
They're selling their twin otter dah.
Okay. So the ID tak sampai setahun lagi?
Tak, 6 months,
6 months.
7 months.
Tapi dah certified.
Just got my approval December.
Oh, okay. Itu lah.
Yeah.
Alright. Alright guys, thank you and welcome. That's very good introduction. So I will do the first phase of introduction by starting with safety briefing. So I got a slide regarding safety briefing. After safety briefing, it is important. During the safety briefing, it is important for you to get to know the situation, the location, what are the to make you guys familiar, and also it is a need for you to know where to go in case anything happen. So I will do safety briefing, and then after that I will do we're going to have a look at the training content and also training schedule, and after that we shall start the first lesson. Alright. So for the safety briefing, so over here, this is a safety briefing in CAE Kuala Lumpur. So welcome to CAE, welcome to you guys. Safety is our priority, so this is a common what they call our responsibility to ensure that you guys safety. So CAE Kuala Lumpur needs everyone full cooperation and commitment to practice safety in CAE Kuala Lumpur. So like usual, safety is everyone's responsibility. So know where are the emergency exit. So you guys familiar where does the emergency exit? Biasanya masuk ikut pintu utama dia, but secondary exit you guys not aware. In case anything happen, you try yourself, try to look for main exit. But maybe there is another exit that is near to you. To ensure your safety, you should be going to the nearest exit. So it is good to know where's the exit. Kalau ada emergency. CAE Kuala Lumpur emergency evacuation plan. So this is talking about the next slide. So this next slide shows you the basic mapping for CAE Kuala Lumpur. So currently is showing you the ground floor, and we got the building, CAE building, and this one is called North Wing, and this side we call South Wing. For the North Wing, this is where we got a simulator. We got 1, 2, 3, 4, 5, 6 simulator inside the North Wing, and this is where the entry that you came before at the Coast Guard, and then here we got the North Lobby. Initially in 2000, if I'm not mistaken, 2007, 6 or 7, they opened up this place. This is the first building that they operated, right up to until 2009. 2009, then only they have operating this side, the South building. So the South building, we are actually on the second floor, but on the South building. And this is the cafeteria. So you guys know where's the cafeteria? You have to go downstairs near the staircase, which is somewhere here. You be able to find cafeteria towards behind the building. So this is the cafeteria, and behind the cafeteria you'll be able to find there is a swimming pool. This is for the training, for the cabin crew to perform their wet drill. And then on the South building here we got many classes. So I will show you our location, our class location after this, which is on the second floor. So main objective is to know your exit. So we got first exit here, number 1. This is the escape from the second floor to the ground floor, and they can pass through to the middle lobby. And then we got second exit here. This is very seldom staircase that we use, because you have to go through pass through here, which not many people aware that there is a staircase. And then we got another staircase here. This is very near to the middle lobby. So this middle lobby, we got staircase number 3, and we got staircase number 4. So people commonly use staircase number 3 and number 4, and then they will exit via this middle lobby. Okay, so this is, I believe you also, some of you may also coming from this middle lobby, and you find your own way to the second floor. So we got another staircase, and another staircase, which is number 5 here. This is very near to the main hall, and also cafeteria. And another staircase, which is staircase number 6, which is at the end of the south lobby. So you can see here, this is another lobby, which is located at the south building. Now, you already know the exit, so where you are heading to. So you are heading to the car park B. So here we got car park B, which is behind CAE building, and this is car park A. Okay. In case of emergency, this is where you need to go. The assembly point is car park B. So car park B, everybody have to, in case of emergency, you go to the car park B, the assembly point. Do not go to the car park A, because in the car park B, during emergency, there will be a designated person who actually looking into the head count. They will perform head count to ensure everybody is safe, to ensure everybody is in the assembly point and not in the building. So you guys should heading to the car park B. During emergency, if you hear any emergency sirens and also announcement, just leave anything that is not necessary. You can walk quickly. You You don't have to run. You can walk quickly towards car park. Okay. So these are the facilities available. In case of fire, and over here we got a fire extinguisher. So in case you are walking through our facilities and you see there is a small fire, do not straight away heading towards car park B. If possible, you can do firefighting first one by using fire extinguisher. There are many fire extinguisher around the building. For example, here we got fire extinguisher here. All these fire extinguisher location require approval for this building to be require approval by the authority in order for us to operate the operation here. So we allocate the CAE allocate the fire extinguisher. And it will be best to know a little bit how to use the fire extinguisher. Where you have to release the pin, pointing the nozzle towards fire, and then you need to press, and do not facing the wind. If any wind coming through, do not facing the wind. Try the best way to not against the wind. Facing according to the direction of the wind is much more better. Kalau you tak tahu, you jangan confuse ataupun panik. You jangan tak boleh botol tak boleh keluar lah dia punya distribution agent. You jangan balik dalam api tu botol tu. Hopefully everything can be fire goes away. So get some help. And then try to shout and then make everybody alert. Alright. Moving to the second page. This is first floor. First floor. This is where Ipoh. This is where our classroom. And this is the nearest exit. And this is CE office. And this is another staircase. At the end of the building, another staircase. Here, another convenient staircase that can be used at the middle lobby, so that you can goes down to the middle lobby. Here, another staircase. So this is a simulator. Now you know we got CE has 6 simulators. For your information, CE has several facilities around Asian region, Europe. And also take a look at the table of content. We already gone through table of content a bit, but all together we got 13 topics. We're gonna cover ground handling, flight controls, landing gear, and also decking, water and waste, fire protect, fuel system, structures, doors, and topic number 9 onward, which is A321 new ACF. So we got Airbus cabin flags, overwing doors, smart flags, ACT, additional center tank, and also cargo fire extinguishing system. So hopefully we able to finish until topic number 8. So starting with the ground handling over here. So remember, the first one is the 321 Neo Gen Fair. Okay. Over here we got dimension. Obviously 321 has a longer fuselage, same height of the fin, and this picture we able to see the sharkless shark. And over here we can see the dimension of the wingspan. Basically not much different if you compare to the 321 with the sharklet, then a little bit longer the wingspan. So the wingspan here you can see this is located at the last week, which is week number 27. Now aircraft manufactured if I'm not mistaken, manufactured after 2015 onward, airline able to plug out the shuttlet and replace with the winglet, or any aircraft that with the winglet, airline able to take out the winglet and replace with the shuttlet. Aircraft that before 2015, if you have winglet, you cannot change to shuttlet. But after 2015, you can have a choice. Airline able to change. So this is an option because Airbus has made modification at the last week, which is week number 27 here. Last week here, airline able to replace, to change. And the shuttlet here, it is made from carbon fiber, and it shows you the dimension of the shuttlet alone. And here is the structure. So we already know that the 320 is Airbus used 320 as a base in order to build 321 or 3D19 or 318. Looking at the 320 as a base, we got several frames over here, which is forward of the wing section and aft of the wing section. In order for Airbus to build A321, Airbus add on 8 frames forward of the wing section, and Airbus add on another 5 frames forward aft of the wing section to make the fuselage longer. Same principle to build A319 and also A318, whereby based on the 320, Airbus removed several frames of the wing section. Airbus removed several frames in order to make the fuselage shorter, and even shorter for the A318. However, in order to compensate the same flight characteristic by having a shorter fuselage, we got a higher vertical fin for the 318. And let's take a look at the range, how far the aircraft can fly. We got a comparison between 318, 319, 320 and 321. And then comparison with the winglet, CO winglet, CO shuttlet, and also the neo. Obviously, we can see 318, there is no neo, and CO shuttlet, there is no neo for 318, because I mentioned this before, because 318 is the worst seller by Airbus, so Airbus not decided to build A318 neo. So there is no neo for 318. But let's compare with 320 and 321. The 320 CO maximum range is 3200 nautical miles. With the shuttlet, you can see extra 100 nautical miles. So shuttlet has a longer range one because of lower fuel consumption, fuel saving because of the shuttlet. The 100 nautical mile difference. And neo can go up to 3700 nautical mile. With the A321, normally A321 has a higher thrust rating. The range here only 300 nautical mile, 300 nautical mile for the CO winglet, CO shuttlet 3100 nautical mile, and CO for the neo is 3700 nautical mile. Okay. This is due to the why you got lower range for A321. Obviously, because A321 has a higher weight, bigger weight compared to other variants. So that's the range. And then looking into the 321, here we got A321-100, -200, and A321 neo. The comparing with that A321-200, very similar to very familiar with, similar to CO, where engine offered by Airbus is CFM 5650 and V25, and maximum takeoff weight is 93 ton, maximum takeoff weight. For the 320neo, Airbus offer PW and LEAP-1A. This is the same as 320. PW 11,000 series, and we can see that the maximum takeoff weight is 93,500. So 500 kilo higher than CO. So it's heavier than the CO for the 321neo. Okay, and here we got some other variant of comparison lah, 320, 319 for the neo and also CO. And over here is the comparison between 320 and 321, which regard to the station number and numbers of frame. We know that 321 has a longer fuselage compared to the 320, and we got frame number 1, which is here. Same goes to A321, frame number 1, and 320 has 87 frame, right up to the last frame here, 87. 321, the last frame is also 87 frame. So macam mana tu? Kata 321 has additional frame, ada extra frame, tapi numbers of frame dia sama. 320 87 frame, 87 frame, 321 pun 87 frame. So macam mana tu? Ini idea? Dia punya additional frame, tadi saya kata ada additional frame forward forward of the wing section, additional frame aft of the wing section. The frame is identified as, for example, like frame 35.1 or 35A, B, C. Same goes to frame 47A, frame 47B, C, something like that. So the identification of frame still 87 frame. So this is just easy for manufacturer to classify and manufacture, and also having identification of the component. So that's why numbers of frame there is the same. However, the station number is different because the station number, for example, like 3500 over here, station number is representing the distance between datum and the location. For example, like the datum on the 320 is taking 100 inches from the nose, or 154 mm, 1540 mm from the nose. So this is datum line. So starting with frame number 1 is 3500. Frame number 1 3500 for the 320, same as 321. Looking at the frame 35, 320 station number is 115,367. Here also the same for the 321. But looking at frame 47 is that you can see there is a difference. Here 25, here 21. So the station number starting from 0 to frame 47 is different compared to the 321. But the identification numbers of frame is the same. Alright. So the frame, additional frame forward of and also aft that make 321 much more longer, and additional frame, of course, it will cause the maximum landing weight is to be increased, and of course the wing structure also will be different. Same goes to the pylon structure, also different compared to 320. The 321 the wing structure, Airbus does not reveal what are the difference in the structure. However, we aware that the 321, the wing structure is different. It's much more beefy, much more stronger compared to the 320. 320 kan dia ada interceptor profile, right? 321 no interceptor profile, but less wing flexing compared to the 320. Alright, looking into the servicing point, there is not much different regarding servicing point. We still have servicing point the same as 320, which is the electrical connection for the ground port. Servicing point for the refueling panel, and also the engine, the hydraulics, which is we got 3 service panel, laboratory, water and laboratory service panel, and also the APUs. Basically, it is the same. The only difference is the middle drain service, water drain service panel. The 320 has this middle drain service panel, 321 does not have this. Why 321 does not have this middle drain service panel? Because of the water tank. Water tank for the 321 located behind, while the 320 located here. There is an overflow port. Overflow port, that is the one that directly from the water tank directly overflow to the middle drain service panel for the 320. Basically, the rest is the same. And then vehicle support arrangement, this is similar to the 320. We still have the 321, same the fuel bowser located on the right hand side, and the left hand side is the optional. 321 also the same. If I'm not mistaken, 321 that owned by Asia took the optional left hand side fuel coupling facilities. So we do have on the left hand side. The other support arrangement is the same for the catering vehicle, for the cargo loading, and also water service panel vehicle. And next one is the turning radius. If you do maintenance, 320, 321 do not, please be aware that the 321 has a longer fuselage, and the turning radius may be different. Normally turning radius with the reference to the landing gear. Landing gear, let's say you turn to the left hand side, the turning radius is referred to the left hand side, the landing gear. So we got turning radius. Over here shows you the turning radius for R3, R5 and R4. So here we got R3, R5, R4, R5, which it tells you the dimension. Comparing 320 here and also 321, let's take one example. Let's say the nose here, which is R5. R5 for the 320 is 18.3 meter. The 321 is 22.6 meter. The numbers is not really important, but the important is if you do any turning, make sure the fuselage or the aircraft component is clear. Be aware that 321 has a bigger and longer fuselage. Alright, moving to the flight control. So flight control 320 and 321, is it the same? Mostly similar. The flight control computers, is it the same? The same, but part number is different for 321. This is due to maintain the same flight characteristic for 320 and also 321. Because we have to remember the concept of 320 for concept of Airbus. Airbus dia keluarkan 320 family, walaupun dia ada banyak variant, tapi pilot dia fly kapal 318 sama aja dengan dia fly kapal 321. So the flight control computers that control the aircraft has different software in order to ensure same flight characteristic. If the airline install or replace winglet with the sharklet here, replacing this, then the flight control computers also require to have a software update. Now, the 321 has similar flight control surfaces. You still have the same slide, 5 slide, same as 320. Single piece aileron, same like the 320. The spoiler, 5 spoiler, same like 320. However, the operation of the spoiler may be different compared to CO, 320 CO. Kalau CO, dia punya spoiler assist, dia bila dia assist aileron, dia sama. Kita ada 5 spoiler, let's say 4 spoiler is flight spoiler. Bila dia assist aileron, dia akan naik pada position yang sama lah. Tapi untuk newer version 320, 321 and 321 Neo, dia punya spoiler travel is graduate, what they call gradual punya position. Mungkin yang sebelah inboard dia naik lebih sikit, yang outboard dia naik kurang sikit, further outboard dia naik kurang sikit. So dia ada a little bit different in term of control of the spoiler. But that one is under the software control within the flight control computers. The THS the same as 320, elevator, single piece elevator and single piece rudder, same like the 320 for the 321. The only difference is flap. For the 321, flap is different compared to the 320. The 320 using a single piece flap, the 321 using double slotted flap. Maknanya dia ada tag at the inboard, dia ada tag double slotted, outboard flap also double slotted. Material different. 320, what is the material for the 320? Double fiber kan? 321 dia combine aluminium alloy dengan carbon fiber. The inboard flap, the main surface as well as tag made from aluminium alloy. Outboard flap 321, main surface is carbon fiber, tapi dia punya tag aluminium alloy. Later on we shall go into the detail for the material. But now we aware that the material is different for the flap. So what is our concern as a maintenance? Kalau ada repair, different limitation, different type of repair. Sebab kalau carbon fiber, flap ni selalu dia expose dengan FOD. Kalau ada kena burst ride ataupun kalau kena ada FOD yang datang daripada landing gear, hit the flap. Kalau ada damage, ada repair, carbon fiber is much more difficult to repair. Kena ada extra work, kena ada because of carbon fiber. But aluminium alloy is much more easy to repair, and the limitation is much more compared to carbon fiber. They're like better aluminium alloy. So that is the flight controls for the surfaces. For the computers is the same. For 321, we got SFCC to control the flap, and for the SFCC is single input from the flap level to the SFCC flap and slide control computers, and this computer will then generate dual output to control flap as well as slide at the same time. For the other surfaces, the main computer is the ELAC. ELAC is used to ELAC 1 is used to control roll, and ELAC 2 used to control pitch. So that is the primary function of dedicated ELAC computer, elevator aileron computer. And we know that the input is coming from the side stick, and the ELAC will then distribute the command signal to the flight computer to control rudder. And ELAC also responsible to distribute command signal to the side computer to control spoiler to assist rolling. Yeah, so this is to ensure turn and coordination. So why the side stick goes to the ELAC as a primary computer? Because ELAC responsible to distribute the information to other computer. This is to ensure turn and coordination. Kalau saya bagi contoh macam kapal kecil ya, kapal ataupun kita panggil kapal terbang nyamuk. Tahu kapal terbang nyamuk? Dia kipas kan? Yang mechanical control. Kalau kita turn aircraft, kita turn the control column to the left, for example, up to a certain time dia akan nose down. So macam mana nak counter? Kalau kita nak make sure turn tu straight aja, macam mana nak counter nose down? Satu, selalunya pilot akan play around with the rudder lah. So dia play around with the rudder to maintain nose and then correct turn and coordination lah. Tapi untuk 320, the flight crew just play around with the side stick to the ELAC. ELAC will then distribute the information to counter the nose down using the flight computer. So you have a correct turn and coordination. Tak perlu, pilot tak perlu ada effort untuk play around with the rudder. Okay. The control is no different. 321 and also 320, it is the same. You still have the same side stick and priority control by using the brief distinctive push button. Rudder control by using rudder pedal, the spoiler lever, flap lever, rudder trim button, and also the THS trim wheel. So it is still the same control for the flight crew. Indication and push button, control push button. 321 has the same FAC and SAC as well as ELAC soft button. Same goes to the SAC computer and also FAC computer. Push button on the overhead panel. The indication for priority control for the side stick, and ECAM indication 321 and also 320 has no different. Or it is the same. And flight control computers, location for the 320 and 321 has no different. We still have the side computer in the forward avionic compartment, and also there's some other side computer in the aft avionic compartment. Same goes to the ELAC as well as FAC. Okay, so not much different. And then looking into the flight control, flap and slack control mechanism. So for the flap and also slack, the flight control is identical. For example, like the lower portion here is representing flap, the upper portion here representing slack. As I mentioned earlier, the flap is controlled by SFCC, flap and slack control computers. There is single input from the flap lever. The SFCC will control dual output. The slack as also slack. So I'm going to explain the flap control mechanism. For the slack, it is similar, it works the same. So let's say the flight crew move the flap lever to the selected position. It sends signal to SFCC. SFCC will then activate a solenoid within the valve block. The solenoid will enable hydraulic supply to drive the motor. And here we got hydraulic motor. The green hydraulic system drive the hydraulic motor. It will then turn this gearbox. It is also goes to the same to the other side of the valve block. SFCC will provide hydraulic supply to turn the hydraulic motor. Hydraulic motor will then turn this gearbox. The gearbox will then move. It will then position move the shaft along the rear spar, and then it will then extend or position the the flap into the extended position. So we got hydraulic motor, turn the gearbox will then turn the shaft. So this shaft is a very long shaft located behind the spar. As the shaft turn, it will then turn the move the lever arm into the extended position. So it will then move the flap. The SMCC will then monitor the mechanical component here by putting position pickup unit, which is the position sensor. We got one position sensor here, one position sensor, and another two position sensor here at the gearbox. This is used to monitor mechanical component, because we don't know during the travel of or during the extension of the flap, we don't know any mechanical linkage break at one side. Let's say one side mechanical component fail, what will happen to the flap? We don't want the flap extend one side only, the other side. If it becomes asymmetric, it will jeopardize the flap characteristic. So to prevent this from happening, the computer will monitor the position sensor. In case anything that move beyond this limit, the SFCC will then take a necessary action. The necessary action is by applying wing brake. Here we got one wing brake, another one at the end. The wing brake will be used to provide clamping to stop the shaft at the last position. So it will prevent the asymmetry of the flap. It will stop at the last position in case any of the mechanical component fail. Okay, so the wing brake is activated by solenoid, using solenoid by the SFCC. It will provide hydraulic pressure to clamp the shaft. It will stop the shaft here to prevent asymmetry. Okay, so the flap and also slab, it work very the same, very similar. We can see that the slab also have hydraulic motor, the gearbox, and also the shaft to position the slab. How it works is the same. The only difference is that the hydraulic supply may be coming from the different. The flap is using green and yellow, while the slab is blue and also green. Okay? Any question? Flap? Senang je kan? Tak ada exam, kurang lah coach. Ataupun tak ada lah soalan sangat. Tak ada exam kan? Alright, let's take a look at the shaft for the slab. So the slab here, you can see a very long shaft that tends to move the 5 slab. And here you can see numbered from root to tip. Slab 1, 2, 3, 4, 5. And you can see this is the slab track. Track number 1 right up to track number 12. So we able to see that each slab dia ada 2 track. You got 2. Number 3 here you got 2, 2 and another 2. While slide number 1, since this slide is very is the longest slide, so you can see there are additional track. And here is representing the actuator where the gears used to turn the slab position. So we shall look at the mechanical component later on. However, we got a very long shaft. And this long shaft, we got a T or joint coupling over here that being controlled or rotated by the power control unit. So this shaft, the T section over here is located in the aircon compartment. Same goes to the A321. If we open up aircon panel and then we can see a component, the same location, you will able to find the T junction inside the aircon compartment. And this shaft is right through to the kill beams. At the kill beam, on top of the kill beam, we able to find the slack hydraulic motor. So this PCU consists of hydraulic motors, where the hydraulic is used to turn a gear. The gear will then turn this shaft will then turn and reposition and position the slack. For the flap, flap also the same, where we got PCU, power control unit located above the PTU for the slack, and you can see very long shaft that used to position the flap. So we got inboard flap, we got outboard flap. So this picture is representing 321 or 320? 321, because you be able to see the flap is double slotted. You got main surface and you got tap. 320 only single surface. Same goes to the upward. So here you can see the wingtip brake is powered from different hydraulic supply. It is solenoid operated, controlled by the SFCC. Looking at the mechanical linkage for the flap track. So this picture shows you the 320 or 321. This is 320 because you got a single flap, single surface. Single surface, and we can see the mechanical mechanism here is covered by this movable firing, and the pink color here we can see this is the flap track. The flap track, the flap here is hang on the carriage. So this carriage is traveling between the track, and then we can see there is a lever arm, and this lever arm is connected to the shaft that we seen just now, that whenever the shaft rotates, it will then move this lever arm, it will then move the carriage. The carriage will then position the flap. And this is the carriage. You can see this is the bolt attachment bolt that used to hang and anchor the flap. And you can see there is a securing bolt and also the to secure carriage. You can see there is a slider to secure carriage on the track. And there is a facilities of fail-safe hook that secure the secondary security for the carriage on the track. And here you can see we got 4 flap track. The number 1, 2, 3, and 4. The flap track number 1, which is representing A, and the rest of flap track, which is representing B, has a different config. The flap track number 1, you can see the carriage is hanging on the track, while the track number 2, 3, and 4, you can see the carriage is on top of the track. It's seated on top of the track. So number 1 is the most important one. This is also representing 320. Look at the difference between retracted and also extended position. The retracted position, the one that we see just now, and then the extended position where the lever arm is moved, the carriage is moved towards the end of the track, and then you can see the movable firing. And you can see there is a mechanical linkage to the firing. Here, mechanical linkage to the firing. As it extends, the linkage is also repositioned to move together with the firing. So this is 320. Let's compare with the 321. The 321, the mechanism is similar. We got the main surface and we got the tag. Okay, so this is double slotted flat for 321. And then we got the lever arm, same like 320. We got flat track, and then we got mechanical linkage. 1, 2, 3 here. This is used to attach with this movable firing. So the flat track for A321, the config is, of course, it has a different in size. However, the design is the same. Where you can see there is a flat track 1, 2, 3, and 4, and track number 2 until 4. The carriage is seated on top of that track. Now let's take a look at the position whenever during retract and also extended. We already see the retracted position, and then this is 321 flat extended position. You can see the angle for the main surface as well as the tap is different. You can see the flat carriage is towards the end of the track, and the lever arm is extended position. And take a look at the mechanical linkage. It's very different in position compared to the retracted position. So it will move the movable firing. Okay. So compare this to 320, 321, and also 320, and of course 321 has more lubrication required, more maintenance required for the 321. Sebab dia ada banyak mechanical linkage, more mechanical linkage, of course we got more tasks to be carried out for the flat on the 321. Next one is a picture of the support carriage. Sorry, it's for the support linkage. Here we got A and B. Here is representing mechanical linkage to the firing. You can see quite a lot of mechanical linkage attachment to the support firing. And here we got another support firing. This one is track number 4, 3, and 2. And between the track we got support linkage. So this support linkage, 3A, 3B, 3C. So this is 3A, 3B, 3C. This is how you cut the mechanical linkage. Here you can see the example, the mechanical support linkage. But for the A and B here, the mechanical linkage is much more. You can see there are many attachment mechanical linkage between the main surface and also tap. Okay? And again, more mechanical linkage, more maintenance required for that 321. Alright, next one is the operation of wing brake. As I mentioned earlier, we got hydraulic motor, the PCU hydraulic motor, and the hydraulic motor will then move the shaft towards the left hand side and also right hand side. The mechanical linkage is monitored by the EPPU or the position sensor, and another position sensor here in case any mechanical linkage breaks. Any of the mechanical linkage break, then you will then send signal to the SFCC. SFCC will then apply the wing brake. Okay. The SFCC also monitor the position, the inboard as well as the outboard flap. because between the inboard and also outboard flap, we have this flap disconnect sensor between the interconnector. So we got interconnector, there is a proximity sensor. Proximity sensor will tell you in case, will tell the SFCC in case the interconnector broke. So it sends signal to SFCC via LGCIU. Kenapa via LGCIU? It is simply because the proximity sensor much more able to be represented or monitored by the LGCIU, and LGCIU will talk to the SFCC via digital bus. Okay, moving the flight control component, anything that you do with the flight control system, especially if you perform testing using MCDU, be aware that the safety, we don't want something stuck in between during the operation and testing, because the flight control may be moved during the testing. And obey the AMM and install warning notices, especially those who are working in the hangar, where you got some other people who also working with the aircraft. And also install safety devices during the maintenance. Alright, we have done flight control. Any question, flight control? Alright, moving further is checking and landing gear and also checking. The jacking point 321 and 320 has similar. It is the same jacking point located upward of the pylon. For the wing, upward of the pylon for the wing, and the nose section also the same. You got the jack pad, you got the wing jack pad. It is 321 and 320 as very the same. However, the 321, make sure you use a correct adapter, because the adapter 321, it looks very similar to 320, however it is not the same. Make sure you use 321 jetpack adapter. But for the nose jetpack 320, 321 is the same, not a problem. Only wing yang tak sama, tapi dia nampak sama lebih kurang, tapi make sure you use the correct. Kalau you pakai 320 wing jetpack, wing adapter ni, you pakai 320 punya, you jack 321, apa jadi? Boleh, you boleh jack. Tapi nanti bila you nak turun, you nak cabut wing adapter tu, takut nanti tak boleh dia start. Walaupun you dah letak grease, biasanya you letak grease, you letak wing adapter. Tapi kalau you pakai 320 punya, you check 321, takut nanti tak boleh buat keluar. Okay, so if 321, be aware that 321 also behind here is the safety stand, same like the 320. Do not apply excessive load, only to support, to prevent the aircraft from tipping over. However, for hangar operation, in case you have no engine, if you have no engine and you try to jet the aircraft, it is good to have a ballast in the forward cargo compartment. Next one is the leveling. Of course, leveling can be done in several ways, but one of the ways is using AIDS or using a few page, using MCDU, so parameter popular. So this is to perform leveling and finding the roll and pitch position. And also, you can another way is using spirit level, which where you can place in the forward cargo compartment. So you can place horizontally or you can place laterally laterally on the floor of the cargo compartment in order to ensure landing. Okay, so the 321 obey the EMM, do not apply any liquid gas, use only nitrogen. Be aware that 321 has a different part number for the brake. The brake is different part number. Dia punya design pun tak sama. Dia punya wheel sama ke? 321 wheel pun tak sama, different part number. Size of the tire also different. The landing gear also different. The landing gear, which the strut of the gear and also the shining portion, the landing gear itself, 321 has different. This is to accommodate the higher landing load. Because 321 higher landing weight, so different part number for the landing gear. Right, next one is water and waste. So water and waste, over here starting with the 320. The 320 main component water system is the water tank. The water tank located at the middle here. The water tank located next to the mixer unit, which can be accessed from forward cargo compartment. So forward cargo compartment, aft panel of forward cargo compartment, if we open up, we are able to see water tank, which is made from composite material, which can accommodate around 250 liters of water. In order to enable water to distribute to the forward galley and lavatory, or to the aft galley and lavatory, it requires pneumatic pressure. So the pneumatic pressure here, we got several devices, for example like check valve, filter, and also reduce valve. So the pneumatic pressure is used to apply to the water tank. This would enable the water to distribute. And optional, we got water tank pressurization using air electrical compressor. Some of the aircraft do have this in order to provide air pressure to the water tank without starting the engine or APU. Asia fleet ada yang pakai electrical compressor? Ada beberapa fleet yang pakai electrical compressor. I tak sure lah apa dia punya registration, tapi ada yang pakai electrical compressor. 320 has middle drain service panel, forward drain service panel to drain out water from the line, and also you can see there is a overflow. Overflow goes to the middle drain service panel, and aft water service panel is used for filling and also draining. Looking at the 321, the principal operation of water system is the same. The only difference is that the location of water tank is different. The water tank located behind, next to the waste holding tank, and water tank for the 321 also the same. It is composite and it accommodates the same numbers of liters. And principal operation the same, and it requires bleed to pressurize to enable water to distribute. And we can see that only two water service panel. The aft water service panel is also equipped with overflow. So here, water tank, the overflow goes to the aft overhead panel. Okay. So that is A321. Next one is the waste system. Now the waste system 320 and 321 has it's very similar. It is still the same. The main system is controlled by CIDS, and over here we got a picture of toilet bowl, water supply, flush control unit. Whenever we press flush button, the flush control unit will open these two valves. It allows rinsing and it allows waste to be directed to the holding tank with the help of vacuum. So the vacuum is coming from the vacuum generator, which only running whenever aircraft low altitude, below 16,000 feet. But whenever aircraft at high altitude, the vacuum is generated from this bypass line to the skin. So we got a low pressure at the outer of the aircraft. So the skin is here. The cabin pressure, which much more higher, will help the vacuum. So it will help to direct the waste to the holding tank. The waste holding tank is made from stainless steel, and here it is equipped with the liquid level sensor, and it also equipped with the rinse connection line. This is to provide rinsing during servicing. So whenever we carry out servicing, we drain any waste, it will also provide rinsing. So the liquid level sensor, whenever it sends high level, the liquid level sensor sends signal to several components here. It will then inhibit the flush control unit, because whenever the water tank has gone to the maximum full level, it will prevent any more operation of flush switch. So you cannot flush it. So that's why we got the rinsing pipe, additional rinsing pipe over here. This is pointing to the liquid level sensor. This is to make sure that the sensor is clean during the servicing. Otherwise, you may not be operating flush switch, even though the waste tank is empty. And here is a picture of the 320 waste tank, and here the water tank, except from the forward cargo compartment. Looking at the 321, the waste tank and water tank located next to each other. The CIDS, the director that control, located in the cabinet compartment. Now let's take a look at the control panel. Toilet service panel, and this is water service panel, drain and middle service panel. So this is clearly show you the 320 config. Looking at the water service panel here, this is 320 or 321? This is 320 because there is no overflow port. 321, the other overflow port. You can see. So you got a handle lever, you got water quantity, and we got four indicator light at the side of the water tank. So the water tank here, this is representing 320. We know that we got 3 drain service panel, and looking at this water service panel, we got 4 indicator light: full tank light, drain valve light, this one is forward, and overflow light. So this light is representing drain valve, overflow, drain valve, and drain valve here. So this light will illuminate due to the valve position, and also the water tank quantity. Now the overflow is located here at the middle. So you got 4 indicator light, and then you got water tank quantity coming from the water tank level sensor. And this is 321 config. The 321 config, you got only 2 indicator light. So this indicator light is representing forward drain valve light, and another one more is the tank full light. So this is the difference. And then another one more, you got overflow to this drain service panel. So the config for water service panel 321 is different compared to 320. Now this picture shows you 320 because there is no overflow. You got 1, 2, 3 and 4 indicator light. You got water tank quantity. You got fill and drain port over here. Now let's compare with 321. Now this is the 321. You can see overflow port and only 2 indicator light. The rest is similar where you got that valve, fill and drain port and water tank quantity. So 320, yang ni you nampak dia black. 321 dia ada port untuk overflow. So if you carry out testing on the water system, be aware lah, overflow just above your head. Kalau you buat testing ke, you kind of maintenance ke, overflow just above your head, because you don't want to end up mandi dengan air daripada water tank. Alright, the FAP that shows you the water quantity as well as the waste quantity is the same, not very much different. For the waste system, 320 and 321 is very the same. There is no difference. You still have the director that control the water and the waste system. And you can see the waste tank. Here is the fluid level quantity that goes to the DEU. DUB will then provide communication with CIDS in order to provide waste level quantity. We got vacuum generator is controlled by the CIDS director. CIDS director also provide information to CMDIU for maintenance test facilities. So basically there is no difference compared to the 320. Okay, so obey the EMM, make sure you clean and secure the toilet component for the lavatories. Be aware that the water heater is hot. If you carry out any maintenance, make sure you cut off the power supply to the heater before directly you carry out maintenance to the heater. Alright, we have done water and waste system. Any question? Alright, I think we stop here. Let's take a 10-minute break. Engine fire protection. Now, the engine fire protection is using the main component is the fire detection unit, which is the computer, and also the detector. So we got FDU, Fire Detection Unit 1 for engine number 1 and FDU 2 for engine number 2. And we got another one more FDU which is for the AE. For the A321neo, the main difference is the numbers of detector. We got one detector at the pylon, one detector at the core, and we got 2 detectors at the fan. So altogether 4 detectors compared to 320 CO, only 3 detectors, but for 320 neo as well as 321 neo has 4 detectors. So each detector consists of 2 loops, loop A and loop B. So loop A and loop B, this is to ensure genuine indication, to make sure that the flight crew receive genuine indication, because the detector is located side by side to each other. Both detector must detect fire in order to generate fire warning. So FDU will then provide warning signal in the cockpit, and this is the fire alarm panel, fire panel in the overhead panel. So it will then produce warning illumination of fire alarm in the fire push button, and the flight crew, in case any fire, the flight crew will then release out fire push button, and then it will cut off the engine, and now the flight crew able to release engine 1 and engine 2, and this will then release engine 1 first bottle and also the second bottle. So once the engine release to the engine to the engine, so you can see here the engine will release to the fan area as well as the core. And in case there is still fire, then the flight crew will release second engine by releasing the second bottle. Also release the engine to the fan and also core. So hopefully fire goes away. The fire bottle located at the pylon, same like 320, the 321 also located at the pylon, but bear in mind that the part number for the fire bottle is different. 321 Neo has written LEAP 1A fire bottle on the fire bottle. So we got two of them. It is not interchangeable with the CEO 320 as well as not interchangeable with the CEO 321. For the APU has single detector wrapped around the APU compartment. It sends signal to the FDU APU, and it will then provide alarm signal in the cockpit. And then extinguishing, we got extinguishing bottle located just before this APU frame. It is located separately from the APU compartment, and this engine discharge may be automatically or manually. So manually can be done by a APU fire panel, and automatically is whenever FGU will activate auto extinguishing system while the aircraft on the ground. Next one, we got cargo fire protection. In this case, we got 320, 321, and the other side we got 318, 319. Focusing on the 321, the detector and the forward cargo, we got 4 detectors at the forward cargo. We got another 4 detectors at the aft cargo, and we got another 2 detectors at the bow cargo. So all together we got 10. 10 detectors send signal to CIDS. CIDS will then provide alarm signal in the cockpit. So compared to the 320 only 2 detectors at the forward cargo, and aft cargo we got 2, and bow cargo we got 2. So we got 6 altogether. So 321 has extra detector due to the bigger compartment, bigger cargo compartment. Bear in mind the fire bottle for A321 still located in the forward cargo. 1 or 2 bottles. 1 bottle for non-EDTO. For EDTO aircraft, we got 2 bottles. Okay, so unlike the 320 is located behind the bulk cargo for the fire bottle, 1 or 2. And looking at the fire protection component location, here is a picture for the fire detector for the engine, smoke detector for the air compartment, and fire bottle for the APU. Alright, so that is the fire protection. We move on to another topic, which is fuel system. Now, before we look into the A321 fuel system, let's take a look at the 320 and also 390, where the config has been changed from the previous version, where the center tank booster pump has been replaced with a jet pump. So jet pump will provide siphoning effect from the center tank, transfer fuel to the wing tank. The jet pump is operated by the transfer valve. So transfer valve will allow boosted pressure to the jet pump. Jet pump will then create the siphoning effect. And then this schematic diagram, we are able to see intercell transfer valve. So this is used to separate the inner cell and also the outer cell, to reduce the wing flexing. And by using this config, the center tank fuel has no direct feeding to the engine. It will always transfer to the wing tank, and whenever the wing tank whenever the center tank empty, then it will stop the fuel transfer. Once the wing tank almost empty, then the intercell transfer valve open, then you have fuel transfer from the outer to the inner. So the center tank will be empty first, followed by inner tank, and followed by outer tank. So the replacement of booster pump in the center tank with the jet pump is simply due to the fuel tank safety, because center tank is the dangerous tank. It is a heated tank, heated by the air compact, so we Airbus reduce the potential of explosion by reducing the electrical component. So the jet pump over here is controlled by transfer valve, which is normally in automatic mode. It will open and it will close automatically depending on the quantity inside the inner tank. In case inner tank goes high due to the siphoning effect, it will stop the transfer valve. So no fuel transfer until the fuel used by the engine has gone to the lower level. Then the transfer valve will open again, then it will provide fuel transfer. So this process will go on and on until the center tank empty, then only the transfer valve will remain closed. So this is the config of A320 and also 320 Neo and CEO. Looking into the config of A321. So this schematic diagram shows you the fuel system config for A321 Neo as well as 321 CEO, which is the same. The center tank has no booster pump. It is equipped with the jet pump, which operated by the transfer valve. And transfer valve will allow boosted pressure from the booster pump to provide the siphoning effect. The main difference between the 320 and also 321, which is the transfer valve. 321 has no intercell transfer valve because the wing for 321 is much more rigid compared to the 320. Over here there is a fuel quantity 6,400. Here is 6,084 kilo for the wing. If we compare with the 320, here is 5,400. Here is 600 or near to 700. So this is already reached, based on these two, is already reached about 7,000 kilo. Compared to the 321, is only 6,000 kilo. So very different quantity compared to 321. So 321 has less capacity for the wing. This is due to the wing structure for the 321 compared to the 320. Looking at the control panel for the fuel, on top over here we have 318 fuel control panel. This is also the same as 320 CO, where we got the push button for the wing booster pump, and we got the push button for the center tank booster pump. And center tank booster pump can be controlled manually or automatically by the button selection. Compared to the 321 here, the center tank push button has been replaced with the push button for transfer valve. So that's the biggest difference in terms of control panel. Looking at the indication. Now, indication here for the 318, 321, and also 320. Let's start with the A321. You can see that the operation of transfer valve and jet pump, there is a direction arrow to the wing tank. Direction arrow to the wing tank. Compared to the 320 here, there is a same indication where you can see operation of transfer valve, arrow direction to the wing tank. This is to indicate the fuel transfer. However, the indication of intercept transfer valve shown here on the 320, but on the 321 has no intercept transfer valve. That's why you won't see any triangle indication. The 318, we do have intercept transfer valve, and you got indication of the booster pump for the center tank, which is provide fuel feeding to the engine. So that is the comparison in which regard to the indication. Again, for the fuel system, obey the EMM, standby fire extinguisher, any maintenance with the fuel system, avoid any electrical device that able to produce spark. Make sure HF transmission is avoided during refueling, and aware that kerosene is hazardous. Alright, moving to another topic, which is structure. Any questions so far? Alright, structure. This is A318, 319, 321, where the structure is identified and separated into chapter. Over here, like 53, 56 for the windows, 54 for the pylon, doors 52, 55 stabilizer, 57 for the wing. Looking at the pylon structure. The pylon is a combination of composite and metallic structure, where the metallic structure for the pylon is used to provide attachment for the engine, forward mount and up mount shown here. And then there is a combination of composite material. For example, here we got some composite. This is to secure the firing, and also some composite material here, and some metallic component, metallic firing over here. This is due to the hot section of the pre-cooler coming from the bleed air. And here is the exploded view of 321 neo pylon structure. And here is the main primary structure, which is made from titanium alloy. And then here we got another titanium and composite alloy for the forward structure. And you can see the pylon fillet is made from composite as well as aluminum combination. And here is the aluminum and also composite for the up section of the pylon. And here we got inconel, which is used to cover the hot section coming from the exhaust, which is inconel and also titanium. And here we are able to see the forward attachment for the engine forward mount, and also attachment for the up mount. And looking into the section of 24, frame 24 to 35, this is 319, 320 and 321. So you can see here additional frame 35. Here frame 35. Additional frame is identified at example here 35.1. There is also 35.2A. So that's, and this representing the additional frame. Total frame still the same as 320, where they identify as 87 frame. You notice that A321 has a large cutout here to accommodate emergency exit forward of the wing section. Later on, whenever we discover A321 ACF, the ACF version, this door has been deleted. Okay. Looking into the kill beam structure, so this is the same for all 319, 320 and 321, where we got the kill beam structure that used to support longitudinal strength to the fuselage. And you can see here the kill beam is there. It is to replace the structure that being taken by the landing gear cutout. So you can see here, this is the main landing gear cutout. Without the kill beam, the fuselage able to distort or crack or suffer from stress easily. So the kill beam is there to support the loss of the landing gear cutout. Here is the picture of center wing box. Center wing box is used to accommodate the fuel for the center tank, and for the 320 it is equipped with 2 overwing exit. While the 321 has no overwing exit. Later on we shall discover A321 ACF is equipped with 2 overwing exit. And next one is the section 16 to 17. This is frame 47 for the 320, right up to frame 70. This is the upper section and this is the lower section. And here is the floor structure. The lower section here, you can see the cutout right up to this aft passenger door, and the cutout of upper skin. You can see there is a section over here which representing a manufactured joint. Now looking into the A321, the upper cutout here, you can see this is similar to the 320, but there is a cutout over here. So this is the manufactured joint between upper skin and also lower skin. So the lower skin, the manufacturer Airbus designed the lower skin where it is equipped with the door cutout for the 321, and the design for the aft section of the skin with the aft passenger door cutout. So it joined together. So this cutout for emergency exit for A321. Later on, you will see A321 ACF. This cutout of this door has been moved further back for about 4 frames behind. So nanti kita akan discover lah. But for now, you know that A321 has emergency exit aft of the wing section and also forward of the wing section. Forward, later on you akan nampak dia akan delete, but aft one dia akan move backward, 4 frame backward. So this is 321 new, 321 ACF, the structure, you will see it is different. Next one is the center wing box and also outer wing box. So center wing box is here, joined together with the manufactured joint with the outer wing box. And you can see here that this is the winglet, which is material is the aluminum alloy, whereby shaftlet material is carbon fiber. And then we got the metallic component, which is behind the slab. And then we got some other overwing panel and also some other accessories for the wing section. Next one is the flap, and this picture is representing A320, where you got a single piece of flap for the inboard as well as the outboard. And between inboard flap and also outboard flap, we got interconnecting rod, which is equipped with two proximity switch, which is used to send signal to SFCC. SFCC will monitor between these two inboard and outboard section. And this is a picture for 320 inboard flap. So the 320 inboard flap, you can see that the main surface here is made from carbon fiber. The internal structure is made from metallic component, which is aluminum alloy. The internal component, which is the rib as well as stringers. And we are able to see the flat track, number one flat track connected to the fuselage, and this is the lever arm, and you can see this is the flat carriage. For the outboard flap, you can see that the skin is made from carbon fiber, the rib and also the stringers here, the internal structure is made from metallic component. So this is the 320. Now let's compare with the A321. The A321, here we can see the inboard flap and also the outboard flap. The inboard flap here, the main surface, here we can see it is made from aluminum alloy. So it's a metallic component for the main surface. But for the tags here also the same, it is made from aluminum alloy. And of course the internal structure, for example like the rib and also the stringers are made from aluminum alloy. Looking into the outboard flap, which is here, the outboard flap main surface here is made from carbon fiber. But the tags here made from aluminum alloy. So it is a combination between aluminum alloy and also composite, only for the outboard. So this is the main difference between 320 and 321. The double slotted flap and also the material. And the material different, the repair and damage limitation is also different. And next one is the composite material around the fuselage, around the aircraft. Similar to the CEO, there is not much different. We already discovered the flap material, composite material for the flap. Some other composite material, we can find carbon fiber on the floorboard, which is represented by this cyan color. And here the whole piece of the THS, including the elevator, is made from carbon fiber, including the rib structure also for the THS is carbon fiber, glass fiber for the forward section, the dorsal fin, the leading edge of the vertical stabilizer, and you can see carbon fiber for the sharplet. The other surfaces, for example, like the spoiler, aileron, carbon fiber, the engine cowling, carbon fiber. The belly is same like the 320. It is a combination between aramids. Here aramid, which is also known as Kevlar. The only difference here is the radome. Radome CO 321 CO, they use quartz fiber. However, the newer version 321 Neo ACF using a different material, which is isovolta series 2. This is new material for radome.
New and old CEO can interchange
Interchangeable.
That's
Radome interchangeable. The radome untuk CO pakai quartz fiber. Tapi kalau diorang tukar, let's say ada repair, kalau diorang tukar new radome, diorang akan pakai isovolta, material yang baru, tapi design konfig sama. 320 Neo CO, mana yang baru diorang akan pakai isovolta. 321 CO and Neo yang baru diorang akan pakai isovolta. Basically diorang nak tukar semua isovolta lah. Kenapa diorang pakai isovolta? I pun tak sure, sebab I dapat feedback daripada composite punya workshop. Diorang kata isovolta ni damage report dia lebih kurang sama je dengan glass quartz fiber sebelum ni. Cumanya mungkin dari segi reliability may be different. Isovolta, Airbus kata isovolta punya material, diorang kata lebih kurang susceptible dengan moist punya absorption. So dia kurang absorb moist. Itu yang diorang kata lah. Tapi report daripada composite repair lebih kurang sama je. Mungkin I pun tak sure detail report tu. Maybe detail report tu is a common damage, FOD ke website ke common damage dekat radome. Tapi new material isovolta. Okay? Pernah dengar isovolta sebelum ni? I pun tak pernah dengar. John Travolta biasa dengar lah. Hollywood punya actor tu. Ini isovolta series 2. I bukan composite expertise. Okay, next one is doors. Starting with passenger doors. So passenger doors, it is the same. 321 and 320 for passenger door is very similar, not much different. You still have the same slide container, lever arm, safety lever, door handle, and window viewing window. A3 overwing exit. A318 has single overwing exit. A319 may be dual overwing exit or single depending on the seat capacity. 320 has dual overwing exit, and 321 has no overwing exit. Dia pakai large emergency exit. Okay. So overwing exit ada. So later on, we discover A321 ACF. Apa jadi pada this door? Dia tak dah deleted kan? So bila this door deleted, dia dah boleh letak passenger seat. Sebab emergency exit tak boleh ada emergency exit kan? So bila this door deleted, dia boleh letak additional seat. So the main reason why Airbus offer ACF A321 ACF sebab boleh letak more passenger seat. More passenger seat daripada 220 boleh tambah sampai maksimum 250. So berapa extra seat? 30 kan? 30 tiket tu banyak lah, macam ikan sardin. Tapi yang Asia punya A321 ACF dia tak sampai 250 lah, dia sampai 235 ke kalau tak silap kan. Tapi it can go up to 250. Normal standard it can go up to 244, tapi you still able to squeeze more by up to 250. Okay. Next one is cargo doors. So cargo doors is the same as CO for the 321. Located on the right hand side, hydraulic operated for forward and aft cargo doors. A321 equipped with the manual operation, manual operated of bulk cargo. Next one is overwing doors. Here the overwing doors opening, removing this flat cover, we gain access to this door handle. So once we pull this door handle, we shall then able to disengage the door from the fuselage, and then we can open it. And this is the E-cam limitation. Now this type of overwing door is Airbus consider this overwing door is not a good design. Why? Why do you think not a good design for this type of door? To me, yang macam ni senang nak maintain, tapi not a good design in term of safety. In case kalau emergency, passenger tu dia duduk sebelah tepi, dia kena buka, tarik fairing, tarik door handle, then dia kena disengage the door, and then they have to throw the door away, baru dia boleh keluar. So proses tu macam lambat sikit. Dia lebih cepat kalau macam ACF yang baru ni, tarik door handle, door tu terus buka keluar, and then door tu dia tergantung, hang on the fuselage. So itu lebih cepat lah. You tak perlu passenger tak perlu tarik and then perlu buang. Dia jadi, kalau dia bagi kat orang sebelah, kita buang. Orang sebelah pula bagi pintu tu kat orang sebelah, baru dia keluar. So that's why it's not a good design, because of the. Now the thing is, bila you tarik handle, door open, proses dia lebih and then dia tergantung. Compare dengan this one, dia akan proses dia lebih cepat untuk keluar kan. So you reduce the time to evacuate. So then this one of the criteria yang you boleh letak more passenger seat. One of the criteria lah to letak more passenger seat. So having more passenger seat, Airbus dia nak kena buat pintu yang cepat keluar lah. Okay. Alright. So working with the door, obey the EMM. The door window here, door cabin residual pressure indicator here, and emergency indicator here. Residual pressure indicator will only activate whenever safety lever is in this arm position. Aware the wind speed for the operation of doors opening. Alright, we have done doors and structure. Any question, guys?
Yang Emergency contact ke atas boleh assisted dengan
Dia ada assistant.
Oh,
Besok kita akan discover ACF. Kita akan discover dia punya detail mechanism. Okay, ada soalan lain? Alright, we stop here for lunch. Alright guys, so we have done the training. Now we do recap, and then we shall then perform Q&A, question and answer, and then we can make conclusion. Now we have gone through the A321 Neo differences. We already has gone through the 321 Neo ACF. Now the ACF version, you know, is very different compared to the CEO. So 321 Neo ACF. Let's start recap with the flight controls. So flight control, what are the difference between CEO and Neo? The flag. Whenever you have different config between CEO and Neo, 321 the flag mechanism using a double slotted flag. And double slotted flag, dia pakai different type of material, which is aluminum alloy and carbon fiber. So different material, repair and limitation also different. So whenever you work with the aircraft, or just aware that limitation is different, obey the EMM. And then whenever the flag mechanism is different, of course you have extra maintenance to the flag system. At least you need to have lubrication, additional lubrication dekat flag system. We have seen that the 321 flag system, dia punya flag ada extra linkage to move the firing, ada extra push rod, and then ada extra support hinge untuk dia punya movement. Okay. And how about differences between 321 Neo in terms of composite material? Anybody? Random is different. The new version aircraft, not only 321 Neo, the new version aircraft, they try to change to a new type of material for the random, which is using isobutol type of material instead of quad fiber. But I believe there are certain new aircraft that still using quad fiber. But to make sure, you have to identify with the company later on. And then that's in terms of structure. How about the water and waste system? The location of water tank is different. 320 located in the forward cargo, aft of forward cargo, where the 321 dekat belakang. And then the control panel, servicing panel is different. 321 servicing panel untuk water and waste, dia ada overflow, and then dia ada 2 indicator light. Is a bit different compared to 320, and 320 has middle drain service panel to facilitate overflow, while 321 dia tak ada middle drain service panel. And then in terms of what else? Waterways, waste system is the same, same like the 320. What else do we have discovered? Fuel system, yeah. The fuel system, the 321 has no intercept transfer valve, where the wing structure is very different compared to A320. However, the principal operation is still the same, where the center tank booster pump, there is no booster pump like the 320. The newer version of 320 has also removed the booster pump. They are using a jet pump transfer fuel to the wing tank. And how about the control panel on 321, which regards to the fuel system? What's the difference between 321 and 320? The push button. The push button 321, the push button that in the center tank is supposed to be booster pump, but 321 now replaced with transfer valve. So if you go to the hydraulic compartment, open up the hydraulic compartment under the wing, you look at the ceiling, you will see transfer valve. It's not a jet pump, it is a transfer valve. And then that is fuel system. How about refueling panel? Is it the same? 321? Yeah, still the same. But with regard to the ACT, additional center tank, but whenever 321 equipped with additional center tank, what are the extra components available? You got extra computer, extra control unit, extra computer, and then you got extra control panel. Especially in the cockpit, you got one overhead control panel to manage fuel transfer for additional center tank, and then you have, how about refueling panel? Yeah, you got extra refueling panel. On the ordinary refueling panel, next to it there is attached together, they piggyback the panel together, is for additional center tank. On the additional center tank refueling panel, later on you may figure out how to perform refueling kalau ada. Kalau tak ada, then tapi the principal operation is still the same. Additional center tank, dia punya refueling panel, dia punya quantity you kena select forward ataupun number 1 ataupun number 2 dekat. Dia ada tunjuk additional center tank total quantity. Okay, so you kena select, dia separate from main tank, wing tank dengan center tank, so separate indication. ACT indication dia lain. Okay, so dia ada 3 refuel valve, the one yang you control automatic or manual. Okay, and how does the ACT fuel transfer to during flight? Using cabin pressure. Air is taken from the aft or forward cargo pressurized area. That pipe will go to the ACT. It goes to ACT, forward ACT. It goes to aft ACT, 1 and 2. So whenever aircraft in flight, the fuel management computer able to transfer fuel from ACT to center tank. So which ACT will be transferred? Depend on the computer. Computer dia akan transfer sama ada forward dulu ke, aft dulu ke, depending on the sequence. Kalau tak silap I pun belum discover. Kalau tak silap dia depend pada weight of the aircraft. Kalau aircraft weight, the CG is too far behind, then it transfer forward dulu, something like that. Kalau too far forward, it transfer from aft dulu. So depend. So this is to trim the aircraft stability. Okay, so that's why they are the fuel management computer. So since using the the cabin pressure to provide fuel transfer to pressurize the ACT and then fuel transfer to the center tank, how about on ground? Do you have fuel transfer on ground? No. No facilities of fuel transfer on ground because you won't have cabin pressure. Alright, so how do you guys access the component in the mixer unit? From the cabin. So whenever you have ACT, especially forward ACT, you need to access forward cabin. You need to access the aft or forward cargo access area from the cabin. Alright, so we have covered quite a lot on the fuel system, and then let's move on to what are other significant difference compared to 320 and 321. Doors. So if we compare 320 dengan 321 ACF, the overwing doors is very different. Where the 321 overwing door is open outward, 320 open inward. So opening outward, you got extra maintenance, especially during in case kalau ada overwing doors tu dia ada problem, ada fault. So what you need to do to dispatch the aircraft, maybe you need to do extra maintenance. Maybe you need to check physical locking system by looking at the mechanical indicator, and then maybe you need to carry out testing on the flight lock actuator. And where can you perform tests of the flight lock actuator? Every compartment dia ada test panel. Whenever you press test switch, you will activate the flight lock actuator regardless of the output of the computer. So you override the computer function to test the flight lock actuator. So once you have confirmed that the flight lock actuator is in lock position, it's just that the indication that is faulty, I think you have to refer MAL, but I think I believe you still able to dispatch the aircraft because it's just a fault indication. But the flight lock actuator must be activated in order for you to dispatch the aircraft. So it's good to have test facilities. So like I said, whenever in maintenance side, I believe we are more like on the 320 lah. 320 punya overwing door lagi senang nak maintain. Tapi walaupun senang nak maintain, ada juga case yang escape slide deploy kan, accidentally. Dulu masa Asia mula-mula buka, were you there? Tak ada. Tapi dulu memang ada case lah. Last year ada case ke? Escape slide deploy. Saya rasa ada kes kan? Ada kes kan? Tapi I dengar cerita escape slide deploy ada I tak sure siapa lah, siap ambil video main slide. Tapi I tak tahu so far what happened lah. Tapi ada satu kes, kalau tak salah setahun lepas ada satu kes escape slide deploy. However, if you perform maintenance, make sure the escape slide is maintained properly, especially whenever you are working with the overwing doors, as well as same goes to the passenger door. Escape slide may be deployed if you perform incorrect maintenance. So the overwing doors 320, the 321, sorry. The 321 overwing doors is oversized by Airbus, and then what are the rating for the overwing doors?
55.
55? 65. 55 was previous version. Initially the door is considered type 3. And then dia up-rated jadi 55 sebab dia besarkan pintu, dapat 55. Masa tu Airbus dah suka. Tapi sekarang Airbus dah dapat satu lagi idea dah besar kan, dia tambah 2 escape slide, dia boleh jadi rating 55 to rating 65. So rating 65 ni lah yang dia guna dekat ACF. So ACF version is 65 rating. And then what physical modification being done on the 321 for door number 3? Door number 3 has been moved further behind. Dia anjakkan ke belakang lebih kurang dalam 4 frame and move further behind because this is to have maintain the rating 55 rating for door number 3. Sebab kalau dekat sangat, no point lah. So you want to evacuate the passenger within 90 seconds. Untuk certified rating, that's why they move backward. And then what are the option of airline to choose ACF?
Indicated door.
ACF ada 2 basic version. Sama ada high density cabin flexibility ataupun ACT. So kalau airline choose ACT, then dia tak boleh dapat high density cabin config lah. Sebab ACT, these two modification, these two option is limited by maximum takeoff weight. Macam tadi 97 maximum takeoff weight. Kalau airline to choose ACT, due to the maximum 97 maximum takeoff weight, they have to reduce numbers of passenger. Kalau airline choose numbers of passenger, then there is no option for ACT. And then we have apa lagi? We cover topic for cabin. What are the difference between cabin for CO and NEO? Is basically the cabin flags. Cabin flags, the main major difference cabin flag is the galley and lavatory, whereby without cabin flags, the lavatory and galley is separate unit. So lavatory satu module, another lavatory satu module, and one whole galley is single module. But now with the cabin flags, airline able to choose the cabin flag by having 2 lavatory and galley in a single module. So single module, pack everything, put everything behind, and they can put more passenger seat in the cabin. So quite smart. Tapi in term of operation, I tak pastilah flight attendant dia punya complain macam mana kan. Tak ada lah. So far I tak ada lah dengar diorang complain order banyak tapi tak ada tempat nak letak makanan. So far I tak tahulah sebab kita bukan selalu dengar diorang punya gosip kan. Diorang punya cerita, diorang punya complain. Tapi so far the airline able to operate this kind of conflict. Lavatory for cabin flags, lavatory, you can see the size of lavatory is very, very small and tiny. And the lavatory, the size is small compared to the previous version. So all new aircraft nowadays is equipped with cabin flag. So airline able to choose whether V1 galley or version 2 galley. Macam Malaysia dia choose V2 galley, different manufacturer, and then this galley is as per picture previously. And then apa lagi? We also discover the cabin Airbus offer overhead compartment, new design of overhead compartment. So which one has more volume to store, to have more storage? The new version. The new version, the door of overhead compartment is lowered, and then you put in. Masa mula-mula training notes ni, I tengok new design overhead compartment, dapat chance untuk terus pergi tengok kapal. Tengok kapal, alamak, bukan new design, dia design yang lama. So far I tak tengok lagi new design ni. Mungkin dah ada yang pakai new design, I tak sure lah. Macam kapal A321 baru sampai bulan lepas bulan lepas apa VAD, I tak ingat lah dia punya registration. Yang tu I tak tengok cabin config yang macam mana. Jadi so later on you boleh try tengok lah. So that's about the cabin config. And how about the config for cargo compartment on 321 ACF? Cargo compartment, we got a fire protection system which is different compared to previous version of 320 family, whereby the control panel is only a single button in order to extinguish fire protection, fire extinguishing agent, which used to qualify EDTO. Only single action. Previous version, the flight crew has to make a double action, which is discharge first agent, after 60 minutes, discharge second agent. So flight manual dia different compared to the flight manual untuk ACF. ACF flight manual hanya mention first discharge. The second discharge is automatically or being discharged by the second bottle by metering of orifice. The first bottle used to provide initial suppression by fully discharge the bottle, and the bottle size for the first bottle is 800 cubic inch, and the second bottle tu dia besar sikit, and the second bottle just used to support the initial fire suppression. Still qualify DTO, and I believe the second one, this is a much more better design lah. Okay. Alright. What else? What is other different for the ACF? Do you think ACF is good and in terms of maintenance?
Additional maintenance, extra maintenance.
Extra maintenance. So dalam arti kata lain, you kerja dengan 320 lagi senang kot. 321 you got additional maintenance task required. What else? How about the 321 in terms of engine? Does the engine the same as 320?
No.
Engine model is the same. Tapi thrust rating is different. 321 thrust rating it can be varies from 30,000 pound thrust right up to 33,000 pound thrust. So rating dia higher compared to the 320. And how about the difference between regarding the landing gear?
Different
The landing gear part number is different. 321 has a larger diameter in order to accommodate larger maximum landing weight. 321 dia lebih berat, maximum landing weight is higher than 320, so they require a bigger landing gear. The brake for 321 also different part number. Kalau tak silap dia punya design brake dia tak sama dengan 320. Sebab dia lebih ikut pada new model design. Airbus dia buat satu design, dia boleh pakai dekat kapal 350, 380, and the new design will be used on 321 neo ACF. So the design due to the config of the brake unit is cannot it doesn't match with 320. So be careful whenever you order spares while working on 321. And how about jacking? 321 dia pakai dedicated wing jetpack. Tapi you kena confirm lah, masa mula-mula memang diorang bagi tahu different jetpack untuk 321. Tapi so far I tak pernah tengok physical lagi lah. Tapi jetpack tu make sure you use 321 punya jetpack. Sebab masa Airbus, sebenarnya Airbus sendiri yang pernah pakai 320, engineer Airbus, bukan Airbus design, engineer Airbus, dia pakai 320 punya jetpack, dia pakai jet 321. Memang dia boleh jet. Lepas tu bila nak remove the jetpack, dia dah di jet, dia nak remove jetpack, Airbus kita dia kena potong structure, dia kena grind structure nak remove the jetpack. So be careful guys, I'm not sure whether they have done something about this. Make sure you follow the correct component for you to perform jacking. Okay, so the training is to equip with you guys to see the difference between 320, 321, and the difference between 321 neo ACF. So far we have discovered there are many differences, not all, but there are many differences between these two variants of aircraft. So we have made the objective. Later on, you may able to look at the physical component of the aircraft. You can have a look at the 321. You are now know the difference between the difference on the 321 ACF. The cabin, the fuel system, in case ada ACT, and then the overwing doors, as well as the external component like the landing gear. Another one more that different compared to 320 and 321 neo ACF. 321 neo ACF dia ada dua oxygen bottle untuk flight crew. Macam 320 ada single oxygen bottle, but 321 neo ACF dia ada dua bottle oxygen for the flight crew. So the bottle is located in the everyday compartment. Two bottle, same location, left hand side. And then for us as a maintenance, we may perform maintenance on these two bottle. Both bottle required to dispatch the aircraft. Dia bukannya satu bottle, satu boleh inox, no. Both bottle required to dispatch the aircraft. And then in maintenance wise, whenever we perform a walk around on the aircraft, we have to make sure that two discharge indicator light remain green for the oxygen bottle. So it is located on the left hand side, the oxygen indicator. So make sure it is remain green on both sides. It's located near to each other. Maybe one here and maybe for about 1 meter or 3 feet away another discharge indicator. Okay, so that is oxygen lah. But so far we have discovered a lot of difference between 320, 321 and also 321 Neo ACF. Okay, hopefully you guys able to look at the aircraft. You have a chance to look at the aircraft later on. Of course, you guys deal with it and you have discovered all the differences in terms of theory. Later on, you can have a look at on the aircraft. So far, so good. Alright. Next, the last one is that I need you guys to fill up a feedback form, and some of you guys have not filled the QR registration yet. Ada yang belum isi QR untuk registration? Yang ni, siapa yang belum register lagi? Boleh isi QR. Yang ni untuk certificate. We want to make sure that you punya nama tu betul dekat dalam certificate. So make sure you